Hi everyone, welcome. So we'll talk about key management and encryption algorithm first, but what is key management? I think I've been saying so much about key management, right? Refers to the process of creating, storing, using, and destroying encryption keys to ensure the confidentiality and integrity of sensitive data. Yes, it's not about just having that key. It's not a lifetime thing. If you do not need that data, then you're going to destroy the key. Make sure you literally destroy everything. And proper key management is a core component of any encryption strategy to protect cardholder data and comply with PCI DSS, comply with standards like PCI DSS. Okay? And this is a life cycle of key management. First, the key needs to be generated. Once it's been generated, you have it in your storage. And then if you want to send it or whatever, that is it is being used. You open it, you use it, you encrypt and decrypt. And then if you do not need it, DLC, you have to make sure that the key is being destroyed. Okay? But let's look at key generation. First, as we said, is a process of creating encryption keys for protecting data. A new encryption key is generated using a secure random number generator for AES, advanced encryption standard encryption, right? And we did mention that already. So process of creating encryption key for protecting data. You have random characters that will be generated. And of course, once they have been generated, it produces and then it encrypts the particular text or information that either you're being stored or you want to send it, right? A new encryption key is generated using a secure random number for AES encryption, right? Then for storage, key must be stored securely to avoid unauthorized access. Common techniques include hardware security modules. This is something that you all can do some research. Or key management system, KMS, right? For example, AES keys might be stored in a HSM to ensure they are protected from tampering. Then talking about key usage, they are used to encrypt and decrypt sensitive data. For example, TLS 1.3 protocol uses session keys to encrypt communication between a web server and a client. And we're going to see that shortly in depth, okay? Then talking about destruction, once the key is no longer needed, it should be securely destroyed to prevent recovery, right? Because if you do not destroy it, somebody get it, of course, they'll be able to recover, right? They can definitely get access to that information or that data. And remember, we're talking so much of being in compliance and also making sure that we are achieving our security objectives. That's a concept of CIA TRIA. For example, when a key reaches its expiration or is replaced, it should be deleted using secure key destruction techniques. You see? Best practices for key management, of course, use strong key generation. Always use a secure algorithm for key generation, ensuring that keys are unpredicted and resistant to attacks. Store encryption keys in secure hardware like HSM or cloud-based key system management that provide additional protection. Key rotation. Regularly rotate keys to limit the potential damage of compromised key. And not really key, you start hearing of PAM, privilege access management, where you have the PAM engineers where they will change, rotate means or privileged users retain their password, so you do not have a password for life. They kind of rotate it, they lock it in a vault. If you want to do certain job, they rotate it, they give you a password. So likewise, talking about rotation, that's something that also happened, and you all can do some research on that. For example, replace AES encryption key periodically to maintain data security. And for access control, implement storing access controls to ensure that only authorized personnel or system can definitely have access to the key. And this is exactly what we've discussed so far, right? But with that, I'm going to stop here and also continue with, we've talked so much about AES standard, but what is AES? Advanced encryption standards. We're going to touch base on other encryption standard and see how it really works. And the only reason of me going out of scope for you all to understand this, it's not like you'll be doing this. Once you're reading that policy, my only thing is, at least once you are reading something on your policy, you need to be able to understand what you are reading, right? Of course, you'll not be the one to implement. They already have all those things running. But if you read your policy, you know what is in scope. If your organization said that they have a particular server where they are managing the key, now you understand that it has to be in scope, right? Or better still, they are outsourcing it to a storage to a third-party service provider. Then you realize that service provider, of course, that's your third-party vendor. Then you want to make sure that they also have the necessary maybe access or physical security controls to limit access, ensuring only authorized users can access that encrypted information that the house. So I'll see you all in the next video, and the tradition. Make sure you subscribe, make sure you comment, make sure you like our videos, and also do not forget to put your comment in the comment section, and as well as any questions, and I'll be more than happy to address it. I'll see you all in the next video.